a break. I want to make sure I can at least get half of it. So 9.6 is applications of distance, rate, and time. Also has our simple interest. So it's a little bit of review from 9.4. And average. Before I go any further, do y'all remember how to do average? Perfect. So that's what we're going to be doing. We're going to be adding some things up, dividing it by however many we have, calculate the average. So to find the average, you would add up all of your quantities that you're looking at, whatever they might be, and to divide by how many quantities you have. So let's say you're trying to find the average test grade. You took 4 tests, so you would add all 4 tests up and then divide that by 4. Now you have your test average. All right, so homework is short, but there's a lot going on with them. So let's kind of get right into it. So the very first question is going to jump into this distance, rate, and time. So if you don't know it, it is D equals RT, where D equals distance. R is your rate. Typically, not always, it's like your miles per hour. This would be your miles. And then your time is like hours. These are just typical things. It doesn't have to be. It could be feet per second. It could be kilometers per minute. I mean, it could change, but the idea is distance equals R times time. All right, so with that, the question is a husband and wife leave their home at the same time and drive in opposite directions? So here's a home. Husband went this way, wife went this way. The husband's speed, we'll call this guy husband. Husband on this side, wife's on this side. Husband's speed is 55 miles per hour. So when you see this right here, the something per something, this is going to be your R. That's your rate. And the wife's speed is 60 miles per hour. So that would be her rate. When will they be 230 miles apart? So we're trying to calculate time. So try to make it as easy as I can. If I take this D equals RT, I can solve for my time by doing what? What's the R doing to the T? So the opposite would be to divide. Hold on. So that would give us distance over rate. We know the distance. We know the rate of each one. I'm going to change it. Go a different route. Sorry. Make this easier. Rather than doing 2 separate equations, I'm going to make just one giant equation. If I know the distance equal rate to time, I don't have to worry about doing literal equations. I don't know time, right? If I don't know something, what do we typically call it? You know? X. T, X, some variable. So if I wanted to calculate the distance my wife traveled, or this guy's, well, not my wife, this guy's wife, this would be 60 times however much time she, whatever the time is that we don't know. You can call it T, you can call it X, whatever you want. And then my husband, this dude's husband, this person here, would be 55T. If I knew the time, then I would know exactly how far they went. But one thing I do know is that together they would be 230 miles apart. So what I can do is, knowing this, I can add these two equations and make that equal to 230. This will avoid us having to produce two different equations and solve two different equations. We can just make one giant equation. Because in this case, what can I do to solve it? Combine the like terms. So 60 plus 55, 115. So now what would I do? Divide by 115. So sorry, y'all don't have I didn't write out the word problem, but the word problem is going to say, when will they be 230 miles apart? So it was given to me. Yeah, so all this information here was given to me. I just wrote it as a picture versus words. But that's a great question, because that'll be given to you. And so 230 divided by 115 would be 2. And since this was mile per hour, this would be 2 what? Ooh. Time. 2 hours. Good. I did see on the homework, it did ask for the units. So make sure you have that down. So I think that's a better approach than what my head was telling me to do. Are we good there? Okay. All right, let's do another one with distance, rate, and time. I'm going to write the equation again so we still have it. All right, this one says Lang drove 200 miles. So we have distance of 200 miles in 4 hours. So we also have time. It's 4 hours. His average speed for the first part of the trip was 60 miles an hour. So first rate was 60 miles per hour, call it R1. And his average speed for the second part of the trip, so our second speed, was 45 miles per hour. Yeah, got late. How long did each part of the trip take him? All right. So we know he traveled a total of 200 miles, a total of 4 hours, and then this was our rate for each one. So using this formula, I can see that my distance will be 200. That's what's given to me. So that's my D. My first rate with the time that I don't know, what would I like to call it? So do I know how long he traveled 60 miles an hour? No. So we can call it what? 60T. I don't know how long he traveled at 60 miles an hour, but for some time, he traveled 60 miles an hour. Plus, he then traveled 45 miles an hour, and I still don't know how long he traveled, but I don't want to bring in a new variable because then I can't solve it. Well, that would mean that they traveled the same amount of time. So this would be like 2 hours and 2 hours, but I don't know that. If I did, I wouldn't have to solve this. So if we start the first one with, I don't know, let's call it T, then the second one would have to be whatever is left of the 4 hours that he didn't travel. So the way you would do that is, let's say hypothetically he did this for an hour and a half, right? If you knew that, how would you figure out how long he would travel 45 miles an hour with? You would minus an hour and a half from 4, but we don't know. So instead, to write an equation, we'll say 4 minus however long I actually traveled at 60 miles an hour. So again, if I knew that this was 1.5, then I would automatically know, okay, this would be 4 minus 1.5, and I would have traveled for 2.5 hours if I knew what T was, but I don't. So when I don't know something, I call it a T, and then I'll say 4 minus whatever that T is.
So are we trying
Yes. That's well, yeah. You don't have to plug it in unless you want to check it. But I'm just trying to get you to understand why this is a 4 minus t, because that is what students want to do. They'll go, oh, it's just 60t, 45t, and move on. But if you're saying that, then you're saying you're traveling at the same amount of speed. So I could just half this and I wouldn't have to do none of this work. I would say, oh, it's just 2 hours each. Like, wow. Yeah. And then in this case, they would both have to be 60 miles an hour. So this is all that I know. Now, also, I get this question a lot. How did I know the 60 went with the T and the 45 with the 4 minus T? I didn't. It didn't matter. I could have done 45 times T and 60 times 4 minus T. I just know one of them is a set time and the other one's going to be for less that, whatever that might be. The hardest part of these problems is setting up the problem. After that, we can use our skills from 9.1 through 9.3 to help us out. So what would I do now to solve? You got to distribute. So we got to get rid of these parentheses, and then we'll be able to combine them back to themselves. So 45 times 4. Yes, ma'am. 180. Good. And 45 times a negative t. Perfect. So 45 times t would just be 45, but then a positive and a negative. Because you asked me, when do I treat it as a minus or a negative? Technically, right now it's a minus, but when I'm looking at them independently, now it's become a negative t. Or you can alternatively look at it as, all right, we'll just drop the minus sign and then do 45 times t and get 45t. So you can look at it in both lights. I know that was one of the questions you asked at the beginning. When do I know it's a minus or negative? They can be interchanged depending on how you're doing it. So for our conversation, I would probably just drop it down as a minus, ignore it, and then go 45 times t is 45t. And then now it's still a minus. Times 4. I had to distribute into the parentheses to get rid of the parentheses. Mm-hmm. Mm-hmm. So now what do I do? Minus 45t. So now I'm combining like terms. It's like I don't want multiple letters. I put a tail on my T so they don't look like plus signs. Go ahead. So technically you're adding a negative, which is the same thing as subtracting. So in this case, I'm doing 60 minus 45. So that would be 15. But that is the same concept as 60 plus negative 45, because you're still going to the left of on the number line. Now what would I do? Get rid of our addition and subtraction. So I'm going to subtract 180. And notice now I'm able to actually do the math beforehand with the little equations. I was just getting more equations back out. Perfect. Ooh, I don't think 0.8. Yeah. So it'd be 20 divided by 15, but that typically does happen. And we'll flip it and say 15 divided by 20 as well. So yeah, this is 20 divided by 15, which is 1 1/3. Yep. Typically, you just put a line above it, and that would be good there. So, um, I think when I put it in, When I did it, I just reduced the fraction. Okay, so 1.33. Perfect. So in that case, 1.33 of its 2 decimal places. Yeah, so this would be, well, it's so the question actually asked how long did each part of the trip take him? So it's going to have a 2-part answer. You would say the 60 mile per hour. Here's your rate, here's your time. It took 1.33 hours. Oh my gosh. Hours. How would I calculate the 45? From 4. And what would you get? So this would be 4 minus 1.33. Would be 1.33 hours that he traveled. And then the 45 mile an hour he did for 2.67 hours. 4 from it. So the question was, how long did each part of the trip take him? So I can say now for the 60 mile per hour part, it took him 1.33 hours going at that speed. And then for 45 miles per hour, he was going at that speed for 2.67 hours. Why he was going at the speeds at the time, part doesn't matter to me. I was just trying to get the math. Maybe it got like me and it gets nighttime and the lights start blinding me, so I go slower. All right, so let's get into some simple interest problem, which we did just a while ago in the last section, but we'll do some more. Remember this simple interest is the IPERT, which is I equals PRT. Do I need me to write out the variables again? Yeah, I remember them. So I was interest, P was principal. That's an R. R is rate, and T is time in years. Okay. So the question is Mark had $15,000 invested for 1 year, some in a low risk stock yielding 4%. So our first rate is 4%. And the rest in a high risk stock yielding 15%. So my second rate is 15%. If his investment has earned, so my interest, $1,997, it's almost 2,000. How much did he invest in each of the 2 stocks? So just like in the distance equals rate times time, we have the same concept here. I know the answer to the I. It was given to me, so that's going to be 1,997. And then I know its rate and time. The time is 1 year, so we don't even have to stress about the time. We can just look at the principal and the rate. If this would have been multiple years, that would come into play. But since it's 1 year, we don't have to worry about it. We can just focus on just the PR. So do I know how much of the 15,000 that I put into the stock that had 4%? If I don't know it, what do I want to call it? The X sounds good. P, X, whatever you want to call it. It says X. That's what the principal that I put in there at a rate of 4%. So what's that as a decimal? Perfect. So I'm going to do this 0.04. So times 0.04. I don't know how much I did, but I know there was a certain amount. Plus, if I did know how much I put in this, how would I figure out how much left I put in the other one? So, uh-huh. Ooh, flip that. So if I knew that, let's say hypothetically, I put $2,000 into this, how would I know how much I put into the 15%? Oh, no, 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 no. So I put $2,000 into the stock that had the 0.04. So let's hypothetically say I knew how much. So I'm putting 2,000 in. How would I figure out how much I'm going to put in the 15%? Very good. I would have to do 15 minus the 2,000, and I would know I'm putting 13,000 into the second stop. But we don't know that. So instead of saying 15,000 minus 2,000, I'm going to say 15,000 minus X. But I will say that's what most students want to do is they'll remember and they'll go X minus 15,000, but you don't know how much you're taking away from the 15,000. And then this would be the new principal, whatever that is, times my rate. But what is my rate in a decimal form for the 15%? 0.15. Perfect. And again, you just simply move these decimals 2 places to the left. So this would be times 0.15. So we good here? So it's very similar to distance, rate, and time, just dealing with different scenarios with money this time. But the setup was kind of the same. So with that said, what should I do? Very good. Doesn't matter where that 0.15 is. If it's on the right side or the left side, you're still multiplying. What is 0.15 times 15,000? 2,250. And then I'm just going to drop the minus sign. And I can actually multiply numbers and letters. So I'm just going to say 0.15x. And then just kind of leave it there. What would I do next? Combine. So even though this is written number and letter, this is technically can be written as 0.04x if you had wanted to clean that up. It doesn't matter if you did or not. But when you're combining like terms, this would be 0.04 minus 0.15. And what would that give you? Go ahead, ask it. That's okay. So I have it written as x times 0.04, but technically it's the same thing as 0.04x. So when I'm combining these like terms, I'm really doing 0.04 minus 0.15, whatever that might be. Very good. So negative 0.11, and then x plus 2,250. Go ahead. It is. That's what I was saying here. This is being multiplied, but it can be written like this as well, where the number can be on the left side or the right side of the x. So that's why I wrote it above it. So like this right here can technically be written as 0.04x, and that means the same thing. Originally, I wrote it like this because I was trying to fill in my spots. So my P was my unknown times my R. But in reality, mathematical grammar wise, we should have written the number, then the letter. Yeah, yeah. Oh, I got you. Yeah, so I can change it here at this step as well. And then it's a little bit clearer on what you're adding. Yeah, no, you can combine them because that's because it's the same concept as like what's 2 times 3? Yeah. What's 3 times 2? So it doesn't technically matter the order. It just looks better when we do the number than the letter. So what do I do next? Perfect. Feel like I'm in an accounting class now. So 1,997 minus 2,250. All right. Now what am I going to do? Good. I'm going to do the, well, negative 0.11. Yep. Again, that does happen to students all the time. The decimal gets lost. Yeah, I get it. Now, before you stress about the negatives, just focus on the number. So 253 divided by 0.11. Ooh, that's a good call. 2 negatives make a positive. That's why I was like, focus on the numbers first and then come to the signs next. Now, let me ask you this as a realistic question. Would it make sense to plug in negative money into a stock? So I want my answer to be positive, right? So, and I totally get it. Like we get it. Oh, it's a negative, and we move on because we did. That's how the math. But in these word problems, do take a step back when you get the final answer. Go, all right, now does this answer make sense, right? And that will help you on some mistakes because you might go, oh, it can't be negative. It has to be positive, right? Now, so what we can do now is I'm going to do the same thing I did with the other one. Here's my rates. Here's my principal. Principal. I had 0.04 and I had 0.15. So how much money went into the 4% rate? Very good. Because that one had just a regular old X. Now, how would I figure out how much I invested in my 15%? And what do I get? Bless you. Taught financial math one year. And this is literally one thing they teach you. Don't put all your eggs in one basket. That's a lot of eggs for high risk. You can get high reward, you can get high loss too. All right. Questions on that? Mm-hmm. Last one we're going to talk about is average. All right. Perfect. Perfect. All right. So look at number 4. I'm talking about averages. We talked about this earlier, but to find the average, there's not like an equation, but you just add up all your quantities divided by however many quantities you added. So in this case, it says, suppose you earn the following 4 scores on the first 4 biology tests of the semester. So you got a 90, a 95, a 97, and a 90. You can exempt the final if your average on the fifth test is an 85 or higher. So now it's trying to figure out what do you have to do on that test. So, oh man, I did it again. There you go. So what we're going to do is, again, to find averages, you add all of them up. And now I'm bringing in a fifth test. Do I know what I made on the fifth test? So it's an X. I'm going to say plus X. But when I bring in this fifth test, I'm going to divide this by what number? By 5. And I want at least an 85 or higher to keep my average so that I don't have to take the final. So that's going to be equal to 85. So I have to make that score or higher. So what do you want to do first to solve this? Combine like terms for sure. So 90 plus 95 plus 97 plus 90. What's that? 10, 13. I'll trust y'all's judgment. So what would you do now? Ooh, this is a great question. Typically, we want to get rid of the constant because it's being added to the variable. But what's going on in this question is I'm technically dividing everything, even that constant itself. So before I can subtract it, I have to get rid of that division of everything. If it was only being divided to one part, I could probably get away with subtracting the 372. But I have to get rid of this division of 5 first before I can do that. So how do I do that? If it was a straight up fraction, I could, but this is just a 5. So what's the opposite of dividing 5? Multiply by 5. Both sides, because what you do to one, you always have to do to the other side. So the 5s will cancel on the left side, leaving me with the 372 plus X. Now I got to figure out what is 85 times 5. 425. Now what would I do? So 425 minus 372. $53. So as long as so she has to make a 53 or higher, and she's exempt from the final. Yeah. I got a lot of students that are like that. They'll try, and they'll go, all right, what's the lowest I have to make to maintain this grade? Well, there you go. Now you got the math. Add them all up, figure it out. All right. I did see on y'all's homework as well. You had to you were given like a bar chart, and then you had to answer a question from a bar chart. So I guess it's more or less at just seeing if you know how to analyze a bar. It wasn't like too much math. It was just you just had to know how to pull it. I don't know how to display that on the screen, so I'm going to try my best to draw what's important here. But we're given some type of bar chart. This is Indiana. And this is 40. I'm not going to worry about all the lines that go around it. See you next week. Be careful on the road. So this is 24 and this is Iowa. We're going to pretend these are straight rectangles. This was 29 and this was Michigan. This was 8. And this was Northwestern. This was 46. And this was Ohio State. I don't know why I capitalized that H, but that's what's going to be now. Yeah, maybe that's what it was in my head. So Michigan, Northwestern, Ohio State, and this would be Penn State. Tim, the toolman, Allen. What is it now? Because he owns the store, right? That's it. All right, so it's going to give you some type of bar chart. It's going to have more information, but this is the important stuff. But the question is using this graph, find the difference in enrollment between the largest university and the smallest. So you just have to be able to look at this and go, what's the largest? Ohio State, which is what number? 46. And then what's the smallest? 8. So when we find the difference, you're subtracting. So what is 46 minus 8? You good? 38. And that's all you have to do. So what makes this question hard is, can you pull the right numbers out? But other than that, the question itself is pretty straightforward. And then I also saw too, because this will sometimes they'll count it wrong. On the side here, it's going to be it's going to say like it's in the thousands. So this would be 40,000s, 24,000s, 29,000s. So instead of it being 38, it's going to want you to say 38,000. So do watch out for that. All right, then there was one more question, and then 9.4 or 9.6 is done, and we'll go into linear inequalities after a short break. So number 6, it says a used car salesman paid $1,500 for a car. That's how much he paid for a car. He plans to sell the car at a 25% discount. So 25% discount. On the market selling price, but still wants to make a profit of 15%. So still wants to make a 15% profit. So what should he mark the selling price of this car? All right. This is a fun little problem here. So we got $1,500. We want to do a 25% discount, but we want to make 15% profit. Okay. Yeah, so what we want to do is we want to show a market price and then say it's 25% off, but in reality, we upped it 15%. So we want to make sure the buyer is feeling good about the buy too. So I'm thinking the best approach to this is let's take our sales price and figure out what our profit margin is. So let's do 1,500 times this 15%. Oh, how do I turn that into a percent? Decimal, so 0.15. So let's multiply this by 0.15 to figure out how much money I actually want to make off this. 225. So I want to walk away from the sale at 1725, and I basically just added this to 1,500. So that's how much I want to walk away from the sale. So I need to upcharge this 25%. So it looks like when I take the discount, the client or whatever is like, ooh, this is pretty good, right? So yeah, right. So I'm going to take this 1725 and I'm going to multiply by 0.25. Right, that's what that is as a decimal. So that's how much I need to upcharge it. so I can take that amount back off of it. So I'm actually selling it for this price to make myself make money. So to figure out the ultimate answer, just simply add this to the 725. And that's truly how this works. When you think you're getting a deal, they've already gotten a deal. Yeah. 2,156. Oh, that's a two. Mhm. Every dollar counts. All right, so this is a good place to take a break. We'll say